Alright guys, we're going to talk about convection currents in the ocean and in the atmosphere and how that drives weather. Alright, so first of all, you should remember convection currents from plate tectonics, and the reason that we had convection currents then is because there were changes in density. So the change in the density actually causes the convection currents to occur. When the molecules are heated, this means that the molecules are going to expand, they're going to get further apart, okay, and the density is going to decrease, causing the material, whatever it is, to rise. When molecules are cooled, they're going to get close together, okay, and the density increases, and then that's going to cause it to sink. So convection currents, we've already learned, are in the asthenosphere. This is what causes the plates to move. That's when we first talked about them. They also happen in the ocean, and this causes the movement of our currents in the ocean. They also happen in the atmosphere, and this causes the movement of the air on Earth. So the cause of convection currents on the surface of the Earth and in the atmosphere, what actually causes this? Well, we just said that convection currents, the changes in density actually is how we get that movement. Well, the thing that causes a change in density is the unequal heating of the Earth. And what causes heating of the Earth? The sun. So the sun is going to cause the convection currents in the water and in the wind. Because the fact that the Earth is tilted on its axis, remember we've talked about this, the heating of the Earth is going to be uneven. You should know this because we have direct sunlight and we have indirect sunlight. So there are going to be different areas that have different amounts of heat in it. All right, here is a picture of convection in the air. All right, so we talked about warm material is going to rise because it is less dense. Cooler material is going to sink because it is more dense. In this case, it is air. So this is going to be the rotation of convection in the air. This happens in the atmosphere. And remember, what causes this is the sun, the unequal heating caused by the sun. So warm air rises because the density decreases. So that means it gets less. It is going to be less dense. As you can look in the picture, it's going to rise. Colder air is going to sink because the density increases. It's going to go down. Hopefully this is a review for you. In the ocean, this also can happen. All right, so the sun is going to heat the ocean. It's going to cause currents. And as you can see, say the sun is hitting here. This is the hottest part. It's going to rise because that's the what happens. The density causes it to rise. It's less dense, and then it's going to sink, and it's going to be more dense. So the cooler ocean currents are going to be sinking. All right, so if you look at this, it's just more explanation of ocean currents. Currents are pushed by the wind on the surface. So the wind is going to push the current on the surface. But if you go deeper into the current, it's going to be influenced more by the sun, by the solar radiation or the energy from the sun, because that is going to cause the density to change. All right, so at the equator, if you look at this picture down here, we have here's our equator. And as you notice, all of the red currents are by the equator. That's because that is where you're going to find the hotter temperatures, because that's where we're going to get most of the direct sunlight on the Earth, because it is, remember, our Earth is tilted. That's where we're going to get the most direct sunlight. So as you can see in this picture, the hotter temperatures here, and you can see this ocean current right here. It's going to start rising. So see, it's rising, and then these down here are going to start sinking. So that is our convection current right there. So warmer water, which is going to be less dense, will move away from the equator towards the poles. So let's look at this. Right here, warmer water, okay, is going to move away from the equator and move towards the poles because that's it rising, okay? If you look down here, same thing. Warmer water is going to go towards the South Pole. Colder water, the more dense water, so let's look at this one, colder water, it's going to move from the pole to the equator. So if you look here, it's starting at the pole, right? And it's going to move towards the equator. Same here. It's going to move from the pole towards the equator. So this is our convection current, and it's driven, again, by the unequal heating from the sun. These are more pictures, right? So don't forget, it also happens in the atmosphere, not just in the ocean. So it's going to happen in both. All right, air pressure. Air pressure is the weight of air pressing against our surface. Air pressure changes as the density changes. So if our density is changing, therefore our air pressure is going to change. So cooler air, which is going to be more dense, is going to sink, creating an area of high pressure. So if you think about it, the colder air is going to go down, and that's going to press down. That's going to be higher pressure. Also note that this is going to bring dry and clear weather. So a way to remember this is high and dry. High pressure, dry weather. High pressure, dry weather. Okay, so the cooler air is going to sink, and that's high pressure. Warmer air, less dense, is going to rise up, and that's going to be low pressure. So it's not applying as much pressure down here. And this brings wet and cloudy weather. So think low pressure, think you're sad, you're really sad, and that's going to bring that rainy and cloudy weather that we don't like when we're sad. So what causes the actual wind in our atmosphere? It's this high pressure and low pressure. So winds are caused by air moving from the high pressure, the colder air, to an area of low pressure, the warmer air. So that density change is what's going to cause the wind to move. The greater difference, the faster the air will move. So if you look here, this is a picture of it, the high pressure going to low. You just have to remember it, it's high to low. All right, and this is just also another reminder, if it's high pressure, that's dry. Low pressure is going to be stormy weather. So high and dry, low and stormy. All right, so another thing that you will need to know is what a jet stream is. Just a real quick, this is what a picture of a jet stream is. So as you can see right here, it's going down. But let's write this information down. It's also it's a fast moving current of air that is really high above in the atmosphere, and they are formed where two different air masses with different temperatures meet. So it's kind of like a border in between two different air masses. It's a fast moving belt of air. So it happens high above the air, it's in between two different air masses, and it moves west to east due to the fact that our Earth is tilted and it's rotating. The result of a jet stream is they push around the air masses and they affect the weather patterns. So they're pushing the different air masses around, causing the weather to change. Right, like I said, and you might have seen this on a weather map. Okay, they happen high above the air, they move from west to east, and they're going to form in between two different air masses. Another thing that you need to know is the Coriolis effect. It is the apparent deflection of very large objects such as airplanes, wind missiles, ocean currents that are moving in a straight path relative to Earth's surface. Okay, so let's think about this. The Earth is rotating, right? It's rotating. And because it is rotating, things cannot travel in a straight path. Airplanes, wind, missiles, ocean currents are all affected by this effect. In the northern hemisphere, objects are deflected or pushed to the right, while in the southern hemisphere, they're going to be pushed to the left. The result is the deflection of winds can cause changes in the weather and cause movement of the currents at the surface of the ocean. So this effect is going to cause airplanes, missiles, wind, ocean currents to be deflected either to the right in the northern hemisphere or to the left in the southern hemisphere. Okay, and that's all.